Here are a couple of related rates problems. These are from the AP website. The first one, you can read that. I won't read it. The first thing for this problem is identify as related rates. So it sounds kind of stupid, but that's important. Obviously, this word right here tells you that it's a related rates question. So with all related rates questions, we start out with a regular equation, which is given. It said the volume of this pile is r cubed over 3. So I'm going to rewrite it so my constant is separate. Then I'm going to read all the stuff that's given. So it says the circumference of the base is increasing at a rate. So this is a rate at 5 pi feet per hour. That feet per hour tells you that that's a linear expression, not a volume. If it was like dV dt, it would be feet cubed per hour. So that's important. So we're going to say the circumference is c. So this says dc dt equals 5 pi. Notice that there's no c in this equation. We have an r. So we have to figure out how c and r are also related. So we'll get to that. It says when the circumference of the base is 8 feet, so we also have c equals 8 pi feet. What is the rate of change of the volume? Which is going to, rate of change of volume is dV dt. So we have everything identified. Problem is there's nothing having to do with r, radius, in this question. You only are given the circumference. So the first thing that I would do is relate circumference and radius. And that's just an equation that everybody should probably know. Circumference of a circle is 2 pi r. So since we're talking about rates, we're going to change this into a related rates equation by taking the derivative with respect to t. Everything here is implicit because there's no t's. So the derivative of c is dc dt. 2 pi is a constant, and the derivative of r is dr dt. So with that, and seeing that we know what dc dt is, we can say 5 pi equals 2 pi dr dt. So dr dt equals 5 over 2. Now, we're also going to need to know what the radius is. And that's why they gave us the regular circumference. So this has nothing to do with the rate. It just is the regular equation. So since we're given that the circumference is 8 pi, we can then find out what the radius is. Divide, you'll get the radius is 4. So these are the things that we have to deal with here with as far as radius is concerned, just given the circumference. So now we can really start the problem. The question is, what is dV dt? And since this is the equation that we're given, we make this a related rates equation by differentiating with respect to t. So the derivative of r cubed, you have to use the chain rule, is 3 r squared. I left the inside alone, times the derivative of r with respect to t, which is dr dt. So dV dt is equal to r squared dr dt. So now we were supposed to solve for dr dt, or dv dt, and we need r and we need dr dt, which were found over here. So you just plug them in. dv dt is 4 squared times 5 over 2, which is 16 times 5 over 2, which is 8 times 5, which equals 40. If you need units on this, well, this is, remember, dv dt. So it's the unit of volume over the unit of time. Volume in this case would be feet cubed, and time is hours. So this would be feet cubed per hour. Hopefully that helped. That's the first of 2 examples. You can look at the next example separately.